Let's take a look at a different video. Take a look at this. This video has incredible camera movement. If we were to achieve such a video purely through prompting, it would actually be quite difficult. So how was this video created? Actually, we combined Uni3C's virtual camera technology with Facebook's recently released SAM 3D technology. You might not be very familiar with SAM 3D technology. However, you should be quite familiar with Facebook SAM, which stands for Segment Anything. This technology can segment any object from videos and images. Today they released SAM 3. Its segmentation accuracy has reached a new level, especially concerning object segmentation in videos. At the same time, they also released a new technology called SAM 3D, which allows it to reconstruct a scene from images. Furthermore, tailored to different applications, they have developed both scene-based and body-based models. So, how do we use SAM 3D technology and our virtual camera technology to achieve such beautiful camera movement videos? Let's take a look now. I have also built the workflow on RunningHub. You can access this platform through RunningHub in the ComfyUI space. RunningHub is an excellent online workspace because whenever new technologies and models appear, it follows up immediately. You can register for RunningHub using the invitation link in my video description, which grants you 1,000 free credits. Additionally, you receive 100 bonus credits every time you log into RunningHub daily. This allows you to try out your own workflows. Alright, now let's look at the workflow itself. The overall structure of this workflow is a WANC 2.1 image-to-video workflow. Let's briefly look at the basic structure of this workflow. First is the configuration section. We configured the width, height, and the total frame count. We loaded the WANC 2.1 I2V14B model. We also enabled block swapping here. We included a LiteX to V acceleration LoRa. These are our encoder and VAE. The prompt I wrote is quite simple, best quality dynamic motion. The virtual camera section is primarily achieved through these two groups. First, we have a control video here. How did this video originate? It came from the SAM 3D technology we just discussed. We loaded this video and then scaled it to align it with our resolution. Let's preview the effect here. I only loaded 81 frames. Next is the application of Uni3C. We loaded a WANC 2.1 Uni3C model. Here are our VA and our control video. Then, we pass it through WANC video encode to generate a latent space. Using our Uni3C model, we process our control video, which finally generates a Uni3C embed, an embedded vector. The sampling process is standard WANC 2.1 sampling. I won't go into detail here. And the final effect looks like this. The reason for this extensive camera movement is primarily due to this control video. We can see that this video has a very wide range of camera motion. Therefore, using it to control the camera allows us to achieve a similar resulting video. Regarding the Uni3C technology, we previously published a comprehensive video that explained it in great detail. If you are unclear about it, you can refer to that video. Okay, now all attention is focused on how this control video was created. As we mentioned earlier, Facebook released the new Segment Anything model, which we call SAM 3. Additionally, they also released a SAM 3D model, which we haven't seen before. Its primary function is to reconstruct 3D scenes based on the images we upload. Of course, this explanation might not be entirely clear, so let's demonstrate it for you now. You can click on the Try It Playground link on the official SAM 3 website. This takes us to a trial usage page. Once you enter this page, you will find that the first two tools are called SAM 3, which is object segmentation. The latter two are called SAM 3D, which is 3D scene reconstruction. Let's look at SAM 3 first. This one is video-based. We can open it. Once opened, you have two options. The first is to upload your own video. For this demonstration, I will use their sample video to show you. First, let's open this video and play it briefly. Notice that the overall video has a fair amount of motion and intense movement. You can simply describe the object here. For example, if we write woman, you will notice that it captures all the women. Then you can click to search the entire video. This way, we can search for all female characters throughout the video. The search is now complete. When we play it again, you will see that the female characters have all been segmented out. You can see the tracking results here, person 1, person 2. You can delete the objects you don't need and keep only the one you require. That is SAM 3's performance on video. I won't demonstrate its performance on images because it is similar to the video process. Next, let's look at creating a 3D scene. Similarly, we can open one of their sample images. We need to go through several steps here. The first step is to add objects, such as this sofa. We can click on it. Note that there's a guide here. You can click Next through segmentation. The sofa can be extracted. Then we can click Add Object to add another item. For example, let's include this stool as well. We can continue adding objects. After that, you can click to generate the 3D objects. Let's wait a moment. As you can see, those 3 objects have been selected. You can add or delete objects according to your needs. Furthermore, you can also navigate through the scene. We can hold the left mouse button to rotate the scene, hold the mouse wheel to zoom, and the right button handles the camera's panning. Of course, we can also upload our own image. Let's start adding objects again. I click on this person. Notice that right now I only selected the skirt. The entire person hasn't been selected yet. So let's click add and include the rest of the figure. Now you see the person is selected. Next, let's add the giant rock. We click add object. Pay attention to the operation method. This button adds to the mask, and this one adds a new object. Now we select the rock. Again, it hasn't been fully selected. We click add again and click on this area. Now the 3D scene for this image has been constructed. However, note that while it can construct people in the scene, the human figures are still relatively crude. That concludes our look at scene construction. Next, let's look at body model reconstruction. We will upload the same image again. After that, it automatically searches for the person appearing in the image. Once the search is complete, it reconstructs the body here. The reconstructed result looks like this. Pay attention, this model includes a skeleton rig. You can use 3D modeling software to edit the skeleton and have the figure strike different poses. But for our current application, you can use the mouse to generate an excellent camera movement animation. Then, record it using screen recording software and edit it slightly. This allows you to generate our driving video, which in turn delivers this superb visual effect. Some people might wonder, is the guided animation effect from 3D scenes more effective? Or is the guidance from 3D human body models more pronounced? I can tell you clearly, the latter effect using the body model is much more pronounced. I also created one using the 3D scene. Let's take a look. This is the navigation animation created using the 3D scene model. Using it as the control video, let's look at the generated result. Overall, the dynamic effect is still very good, but you will notice that the camera guidance is not as impressive as the previous result. Therefore, if you want to achieve exceptional camera control, you should prioritize the 3D human body model. Thus, you can see that the emergence of new technologies makes effects that we previously thought were very difficult to achieve much easier. So what are you waiting for? Go ahead and try it yourself. Follow me to become someone who understands AI.